Well, greetings, students. Sorry I cannot be at class with you tonight. It's Tuesday night around 6:30. You all probably know by now that I've been pretty sick for the last week and a half, and I'm going to have to wait a while yet to get fully recovered from this. So at least this will give me a chance to discuss this with you online. So we'll get started right away with this. The first thing I would like you to do is look at your email, and you'll see that there is a drawing in there. It happens to be the drill tap bore plate drawing. It's a JPEG photograph basically of it, and you can print that out if you want at home, or you can just open it up for reference as we go through the final threading operation here in the drill tap bore. Okay. So the first thing I want to talk about right now is the tool itself that we're going to be using. As you know, previously in boring this out, the 9/21/9 bore, you know that we had to use a 3/8 inch end mill to be able to bore this out because we didn't have enough ramp in. So we want to make sure that we have we consider the same things, okay, for doing the thread milling, because thread milling is going to be pretty much the same as end milling, only this time we're going to cut a spiral at the same time, simultaneously with our moves in X and Y and Z. Okay, so to just illustrate a point, if I were to use a 1/2 inch diameter thread mill, let's just see what that would look like. Let's just say that that represents the 1/2 inch thread mill. All right. If that being the case, this outside diameter here, or the very largest of diameter of the thread, is 1 inch. So what is the distance between here, at this point right here, out to there, or here, I'm sorry, here out to there. So I'm going to go ahead and I'm going to create a point there just so we can sort of see what that might look like. And I'm going to create an intersection right here. And then I'm going to calculate the distance between that intersection and the major diameter of the thread, which is 1 inch. So if I were to check that out and click on this and click on that, I notice that I have a movement of 250 thousandths. So that is enough to use a 1/2 inch diameter thread mill. Usually the thread mills are a little bit undersized anyway, probably about 4 or 5, maybe 10 thousandths undersized, depending on the manufacturer. But we're still going to program it for a 1/4 inch move here. So getting this out of the way then, we have to take a second look then now at the major diameter of the thread. We all know that a major diameter of a thread, of an ID thread, which is what the case is here, if you were looking straight down at the top of this, and you see I have dotted lines here, as I'm showing you now, that dotted line means that you can't see the actual cutting of that major diameter of the thread at this view. That's because it's hidden from you. The only thing that you can see in the top view here is your counter bore and your 9/21/9 bore. And you can see your tapped holes, but you can't see the threads of the tapped holes either. Excuse me, because they are hidden. So we want to make sure that we understand that we need to use the major diameter as our target. From the center of position 13 over to this edge, the target is 1 inch diameter. So we're going to move over there 1/4 of an inch with our 1/2 inch thread mill, and then we're going to create the spiral and go down. So let's take a look at what the pitch of the thread is. Take your calculator, and you take, we say right here it's 1 inch 12, right? So 1 divided by 12 inches, or 12 threads per inch, is 0.0833333. So that's the amount of pitch, meaning that when you make one full spiral, you should advance downward 0.08333. that will produce the thread that you're looking for. So, and we're going to do this in one shot. The thread mill is going to go down to the bottom plus a little extra. It's going to go around one full 360-degree sweep. It's going to ramp out and get out of there. So that's going to be our move. All right, so we have the pitch of the thread. Let's take a look at the thread itself. And I'm going to bring this up just so you can sort of see what this looks like. If I look at the thread mill itself, it's going to look like this. It's going to have a tool diameter out here of 500, ½ inch, or just a little bit less. The flute length from here to here has to be at least 1 inch plus, because we have to cut all the way through this piece. So when we think about this thread mill, we have to select one out of our tool crib that's going to have a cutting length of at least 1.25 inches. Maybe 1 1/8 minimum, but 1 1/4 is probably a fairly common length. So you want to make sure that when you're thinking about this and thinking about cutting this thread, that you go to the tool crib and make sure that you have a distance flute length that's longer than the actual depth of the part, which is what we have here. The body of this, which is recessed from the thread diameter, usually is 50 thousandths or so smaller in diameter, so they can cut this thread out here. So I'm going to say that that is a shank diameter of 450 thousandths. Okay, so that's enough of information, because you're going to be doing this. Basically, you're going to be going to your tool crib and checking this out, what you have, and we're going to see what thread mills we have, what you have in your shop to be able to create this part. Okay, so the next step then is to create the NC code to put this 1 inch major diameter thread ID into this part. You'll notice right away in your drawing that your lower left-hand corner is your part 0. So you want to move over 1 inch 125 in X and move up 1 inch in Y to get to position 13, which is the center of this part. We're just going to do this first one here. We're not going to do the others right now. I want you to basically to finish the other two yourself. So I'm going to create the code for this, and then we will discuss what is actually happening in that NC code. So file NC code. It'll bring it up. You'll notice here that I have my program number, which is what you have on all of your other programs that you've written. We have our safety line, which has the G17, G90, G20, so on and so forth. We have to make sure we have G54 activated. Miranda, I know, has shown you out there the different registers, the work registers, which is your G54, and then, of course, your tool registers. So this is going to be tool number 5. We're going to set it at S500, 500 RPMs. M6 is going to be, of course, a command to do a tool change. M3 is clockwise direction. M8 is turn on the coolant. And then in our rapid move up here, GOO, we're going to go to our first set of coordinates. Okay, X 1.125, Y1. All right. Then we're going to, again, use G43, just like you have for all your drilling and tapping operations and your boring operations. G43, Z100. This time it's going to be H5, because we're going to use tool number 5 as our thread mill. And D5 will be, of course, the diameter of the thread mill, which will be a ½ inch. Excuse me. So you'll still have to have this, basically, this shift in Z value for your tool, as you had previously. And then the next thing we want to do is we want to wrap it down into the bottom of this part plus extra. So you'll see here that I have Z minus 1.0167. That's just a choice. You could go down there 50 thousandths below the part, like 1 inch is 0.50. You just have to remember that whatever you make this, you have to make sure that it's below the bottom of the part, number 1, and then add onto that your pitch, which we said was 0.08333. So if I add 0.08333 to the 1.016, take your calculator and do that, and you'll end up with 1.100. So then that means that my full penetration will be 1.100 when I'm done doing my 360-degree spiral. So let's see how this works out. The first thing I have to do now that I'm down to a depth of 1 inch 0.16.7 is I want to do my ramp in, which is going to be my start point, just like it was for your milling your pockets. So G01, G42, and you say, where did you get the X 1.625? Well, we said it was a ½ inch, right, from here to here, right? So you add a ½ inch to 1.125, and you end up with X 1.625, and your Y value is still 1 inch. Then you're going to put a feed rate in here and a depth of Z minus 1.0167. It's already there, but you put it in there as a safety precaution. So that just says that we're in position right now. We are now right here, right in this position right now. We have ramped into that point. That is our start point. It is also going to be our end point. Let's see how that works out. So we start our spiral, GO2, clockwise. So that means we're going to start in here and we're going to rotate in a clockwise direction all the way around and back to the same exact spot. So if it's the same exact spot, I should have X 1.625, which I do, and Z1. So that's my start point, and now it's my end point. Notice, though, that I have advanced in Z at the same time or simultaneously, and look where I am now. I was at Z minus 1.0167, but when I finished the spiral, I ended up with Z minus 1.1. And we calculated that as taking 0.08333 and adding that to 1.0167 to equal Z minus 1.1. Then we have to put in our I and J values here. And of course, we know that this is incremental. So if I'm out here and I'm looking to my left, I'm saying that is the center of my arc. That is an I value of 0.5. It is minus 0.5 because if this was a little Cartesian coordinate right here at my start endpoint, if I were to look to the left, that would be an I minus value. So that's exactly why you see I minus 0.5, and our J is 0 because we're still on this plane. We have not moved off this plane, which is parallel with our Cartesian coordinate down here at the lower left. So at the end of the spiral then, we want to cancel the G40. So we're going to ramp right back out where we were before. So we're going to go from here and ramp back to position 13 right there. And there it is, G01, G40, X 1.125, which is what this is right here, right? And Y1. And then we're going to say GOO, Z.100, come off the face of the part and cancel. And if we're going to do the next 3 holes, we won't have to have either of these two. These two will not be here. But what you'll want to do is you'll want to rapid that over to position 14 next, and then over to the final position 15. So that is going to be your homework assignment. I'm going to copy this right here, and I'm going to put this and attach this to the other documents that I sent you in the email, and also the video. And when you open up the video on YouTube, remember to double click on it, open it up, and then click on Theater View. Look at the bottom of the screen, it'll say Theater View. Look at that, or you can zoom into it all the way if you wish. All right, that's it for tonight. Have a good night. Talk to you soon.